In our eConnect classes, we have started with the module 2, that is from the half part of module 2, that is we have started with the sampling, and then we have covered all the topics in the module 2. Then module 3 we have learnt regarding sedimentation and filtration. All aspects we have covered in this. Then disinfection, that is module 4, we have studied regarding disinfection and miscellaneous treatment. Then in the module 5 we have covered on collection and conveyance of water. In that we have studied regarding the different type of pumps, then the pipe apparatuses, valves, then pipe material with their advantage, disadvantage, then distribution system. In this we have covered on gravity pumping, then combined pumping, then the types of distribution system, service reservoirs, and the different types of it we have covered it. Now in module 1 we have covered this in our regular classes, that is our theory regular college classes. We have already covered these particular module 1, but again we will have the repetition of module 1, so that our eConnect classes series is going to cover all the module that we have learned. Okay, that we need to learn it. So in module 1 we will be seeing regarding the introduction. In the introduction we will be seeing regarding the need for protected water supply, then demand of water. In that we are going to see types of water demand, that is domestic demand, industrial demand, institutional demand, commercial water demand, public use, fire demand and its estimation, factors affecting per capita demand, then variations in the water demand, and then a peak factor, then what is the design period, factors of affecting the design period, and the methods of population forecasting. Numericals we have already solved in our theory classes, so just we will repeat the things, the theoretical things what we have covered in the module 1. Now first we will be seeing regarding the need of or your demand of water. Now in today's class we will be seeing what is water demand. In that we will cover the types of water demand, that is it is going to have the 5 types. First is residential or domestic use, then institutional, then public or civil use. In that we are going to have the 4 types under it. Then on fire demand we are going to cover which are the different formulas that we are going to use here. Then we will be seeing on the industrial use, and again there are tables are there which already I have covered in our theoretical classes. So I will be just briefing it, what is industrial use, what is institutional use, then what are the various water system losses. So this much we are going to cover, and if the time is available then we will cover some of the other aspects also. Okay, now first is regarding water. Okay, water is very essential part of the human life. Okay, after air, the thing what we require in order to serve on this particular earth, we want the next after air is we want the water. Without water the person cannot able to imagine the life of his life. Okay, so water right from the start of the day till the end of day, at each and every maximum time we need water, help of water. Might be in a residential area, might be in an institution, might be public or civil, might be industries. Okay, and there are different areas where we cannot able to imagine our life without water. So water has become very essential, essential and most important part of our life. So whenever we need to have the water, we need to understand what are the different types of water demand are there. Now what is this particular water demand is? It is, as the name is indicating, the water demand. That means the water requirement. Now coming to an individual person, now let us define this. What is this water demand? It is an amount of water required by a per person per day, is we call it as the water demand. I'll repeat, it is an amount of water required by per person per day. That is nothing but we call it as an water demand. We usually short form this in terms of LPCD. What is this LPCD? Liters per capita per day. Okay, liters per capita per day. Liters is nothing but it is unit of your liquid. Then per person, how much amount of water he requires in a day, that is LPCD. If you want to remember this water demand, you can remember this LPCD. It is liters per capita per day. Then if you remember this LPCD, then you can easily able to define what is water demand. Now here in water demand, we are going to have the different types in it. The first type is the residential, where we live. Okay, we require a water for various purposes in our house. An average person may consume not more than 5 to 8 liters a day in a liquid and the solid foods, including 3 to 6 liter in the form of drinking water, milk and other beverages. Okay, now however, the per capita consumption of water drawn from a public supply is quite large. Okay, the total water requirement has been divided into the different types of it. So in a residential area, okay, in a resident, what different activities we perform? Okay, right from your bathing, right from going to the WCs, right, house washing, washing of the utensil, cooking and drinking. Each and every area we require the water for the different purposes. Okay, the provisions according to the Indian standard, that is IS 1172/1957, again it recommends that according to the Indian conditions, we require how much amount of water? We require around 135 liters of water per person per day. Amount of water is required by each and every person per day. Okay, this is per one person. In Indian condition, the amount of water required by per person is 135 liter. So this you need to remember. Okay, now how you are going to consume this 135 liters is, okay, in bathing, per person may require around 55 liters per day. Okay, then washing of clothes, he may require around 20 liters. Then flushing in WCs, per day he may require 30 liters of water. House washing, he will require around 10 liters of water. Washing utensil is 10 liters. Then cooking 5 liters and drinking 5 liters. If we combine all these, it is going to become 135 liters. So it is very important to remember 135 liters of water per person per day he requires in the climatic conditions according to the India. Okay, so this is regarding the residential or domestic use, the amount of water that per person per day he is going to consume in the for the domestic or the residential purpose. Okay, this is regarding the residential or the domestic use. Now when coming to the institute, it is the amount of water that is required for the various institution purpose. That means the office kind of a purpose. So here we are going to have the different categories. I have already dictated how much amount of water for the different type of institutes we require. I have already told in the theoretical classes. Since the table is very long, I'll just I'll mention the names and along with the water requirement. Okay, so here in the institution we are going to have hospitals, hotels, hostels, then boarding schools, restaurants, airports, terminal stations, then day office, your day schools and colleges, offices, factories, cinema, concert and hall. All these will be considered under the institutional type of segments. Okay, for hospitals, again we are going to classify it into two types, that is depending upon the number of beds. Okay, if the number of beds it is exceeding more than 100, then per person how much amount per bed, how much amount of water is required? That is 450. Then number of beds not exceeding than 100, it is 340 per bed. Then for hotels, it is again it is calculated based upon the per bed. So per bed requires around 180 liters of water. Then hostels, it requires, the residential hostels, it is going to require again as our residential water demand, that is 135 liters. Then nursing homes and medical quarters, it requires 135. Boarding schools 135. Restaurants, it requires 70 liters per person per day. The airports and seaports, it is a 70 liter LPCD. Then terminal stations, it is 45 LPCD. Day schools and colleges, it is 45 LPCD. Offices, it is going to require 45 LPCD. So factories, it requires 45. Then cinema and court halls, it requires around 15 liters of water per person per day. This we have already discussed, so that is the reason why I have not focused too much on this while by drawing all those numbers on this particular paper. We have already covered in our theoretical classes, just I have highlighted. So this is a chart of the institutional water demand, which is going to have all the 14 categories along with the liters per head per day usage, and depending upon the different types of institutes, and along with its water requirement, and along with the remarks. The next type in case of your types of water demand is it is for public or the civil use. These are normally it is going to be utilized for the public facilities where we are going to have. So in that, the first is for road washing, that is for cleaning of the roads, then for sanitation of the public lavatories. Okay, then third is the amount of water required for the public parks, that is for gardening, and then for the firefighting. Okay, so in this the first is for road and municipality area. Okay, we require around 5 liters per head per day is going to be utilized, and similarly for the sanitary purpose, for that cleaning of the sanitary blocks and flushing of a sewer system, whichever is going to be provided at a local the local places, we will be having the various public lavatories and all. For flushing them, we require around 3 to 5 liters per head per day. It is going to be used. Then water requirement for the maintaining the public parks, that is 2 to 3 liters per square meter per day. It is usually for public parks, how much area is there for each square meter, we require around 2 to 3 liters per square meter per day we are going to use. Then might be next is your firefighting is these fire accident, they happen the accidentally, so we need to have good amount of water for this purpose also. So here for firefighting, we will be calculating the amount of water requirement by using the various formulas, that is the Kuchling formula, Buston's formula, Freeman's formula, and National Board of Fire Underwriters formula. By these different formulas, we will be calculating the amount of water required for the firefighting. Okay, here the Q is nothing but the quantity of water in liters per minute. Okay, that is nothing but we usually call it in terms of it as a discharge, and P is the population is in thousands. Okay, depending upon the quantity of water in liters per minute, and depending upon the population, how much amount of population is there, depending upon that we are going to calculate it. So first is first formula for the firefighting is, we call it as an Kuchling's formula. So it is given by Q is equal to 3182 square root P. Then by Buston's formula, we are going to calculate it in terms of Q is equal to 5663 square root P. Then Freeman's formula, Q is equal to 1136 P divided by 5 plus 10. Then National Free Board Fire Underwriters formula, we are going to calculate it as Q is equal to 4637 square root P, and under the bracket 1 minus 0.01 square root P. So this is the National Board of Fire Underwriters formula. Normally this we are going to have one particular problem in your examination. They will ask you determine the amount of fire water demand for firefighting if the population is etc. If it is given, then from that particular population you can directly calculate the, for usually this population will be given to you in the problem, and if the population is given, by using these different kind of formulas you can easily determine the quantity of water required in case of the fire accidents. You can easily calculate. For this we have already solved one problem in our theoretical classes. Okay, now for firefighting, a huge quantity of water is going to be required in case of a fire accident. Okay, the fire hydrants of around 15 to 20 centimeter dia are normally it is utilized in your fire accident, and that too the high pressure is required, because if the water is there but the pressure is not there, then it is not able to extinguish that particular fire. So we require a pressure of around 1 to 2 kg per centimeter square amount of pressure is required. Okay, according to the American Insurance Association, the amount of water required is around 40,500 liters per minute. Okay, assuming the total consumption of 150 liters per capita per day. So this much of amount of water is going to be required in case of your fire accident. However, the provision for fire is made for 3 to 5 hours of fire flow. So there is a huge amount of water is going to be required in case of your fire accident, and whenever the public or civil use you are going to consider, so you should also consider these firefighting, which is going to be very important aspect in case of your public or civil use. Next is your industrial use. See, when industry is going to, the development of any nation is dependent upon the industry. So if we need to have the proper growth, financial growth, then we need to supply water to these particular industries, because industries, they run with the help of water. So we need to provide an adequate quantity of water in case of your industry, in case if you are going to run the industries. Okay, so the presence of industries in or near the city has a great impact on the water demand. Wherever we are going to have the industry, we need to supply the good amount of water. For a city with a moderate factories, a provision of around 20 to 25% of per capita consumption may be made for this particular purposes. So we will next we will see how which industry requires how much amount of water in one particular table. Now let us see the table of the water requirement for a different kind of an industry. We are going to divide it into the three categories. That is, we are going to have first in the first column we are going to have the industry. The second column is unit of production. Then the third column is water requirement in kiloliters per unit. So first industry is, we are going to have the 11 industries in this. So first industry is automobile industry. It is unit of production is per vehicle, and the amount of water required is the 40 kiloliters per unit. Okay, then distillery, that is the unit of production is in kiloliters, so then we require around 122 to 170 kiloliters per unit. Then fertilizer, it is unit of production is ton, and we require around 80 to 200 kiloliters per unit. Then leather industry, it is in terms of 100 kgs that we require, unit of production is 100 kgs. Okay, then the water requirement is in kiloliters, that is we require 4 kiloliters. Then paper, it is the unit of production is ton, we require around 200 to 400 in kiloliters per unit. Then special quality paper, it is unit of production is in per terms of ton, we require around 400 to 1000 kiloliters per unit. Then a straw board, it is unit of production is in ton, we require around 7 to 100 kiloliters per unit. Then petroleum refineries, it is in tons, 1.5 to 2 kiloliters per unit. Then steel industry, it is in tons, so we require 200 to 250 kiloliters per unit. Sugar industry, it is in tons, 1 to 2 kiloliters per unit. Textile, it is in terms of 100 kgs, we require around 8 to 14 kiloliters per unit. So this is what the different types of industries require the different quantity of water in case of your industrial use. The fifth type is the water system losses. In this, we are going to have the losses from water distribution system. It is going to have 5 types in it. In this, first one is due to the leakage and overflow from the reservoirs. Then leakage from a main and a service pipe connection. The third is leakage and losses on consumers' premises when they get unmetered house supplies. Then under registration of supply meters. And then fifth is the large leakage or wastage from the public taps. Okay, now when we see regarding the water system losses, that is sometimes what is going to happen is due to the leakage we will be losing a huge amount of water, whatever the water we are going to supply to the public, depending upon 135, considering 135 LPCD. If there is an leakage is there in the system of supply, then we will be losing a huge quantity of water, and ultimately what may happen is it may not reach the consumer. Okay, so that is the reason why we should consider these system losses also when we are going to design the water supply system. The leakage from main and service pipe connections also we should consider. Then leakage in the consumer's premises we also should consider. Then the leakage from the public taps, all these things should be considered. Okay, then losses in the supply lines are mainly due to the defective pipe joints, cracked pipes, and the loose wall fitting. In case of a well maintained and fully metered water distribution system, the losses may exceed only up to the 20% of the total consumption. In a system where the supply is partly metered and partly unmetered, then the losses will be considered up to the 50% of the total supply. So in today's class we have seen what is the different types of water demand, and then we have seen the different types of water demand, and then what is residential water demand, institutional water demand, along with the different categories. We have seen the table for this, and then the public water supplies or civil use we have classified into two, where road washing will require 5 LPCD, then sanitation will require 3 to 5 LPCD, public pass it require 2 to 3 liters per square meter per day. Then firefighting we have seen Kuchling formula, Buston's formula, Freeman's formula, and National Fire Board formula. We are going to use the this particular formulas depending upon the population in terms of thousands. We are going to calculate all these different amount of water requirement for firefighting purpose. Then industrial use also we have classified, and we have seen the table for the different water industry, how much amount of water is required. Then what are the water system losses? It is mainly due to the leakages. Here if the system is well maintained, then we will require around 20% of extra water, and if it is not unmetered, then we may require the 50% of extra water supply of the total consumption. So this is what regarding water demand. Water demand is nothing but how much per person, how much in a day he requires of water. LPCD, amount of water required by per person per day, is nothing but your water demand. In tomorrow's class we will be discussing regarding the various factors affecting the rate of demand. In this we are going to have the 11 categories. Even in this particular class it will take too much time to explain, and our class is going to extend. So what I will do is I will be able to handle these particular factors affecting the rate of demand in the tomorrow's class. But we'll see what are the different types of types are there in this factors affecting rate of demand. In this we are going to have size and type of community, then the standard of living, climatic conditions, quality of water, pressure in the supply line, the system of supply, then sewerage and metering conditions, then water rates, age of community, lawn sprinkling. There are around 11 types are there in this. Then we are going to discuss on variations in rate of demand, and then factors affecting factors affecting the per capita consumption. That we are going to discuss in tomorrow's class. Since the time is limited, so I cannot able to continue with that. So we are going to discuss regarding these particular aspects in our next class. Thank you.